Welcome to AI Frontiers. Today's episode, titled AI and the Self-Evolving Software City, explores how artificial intelligence is fundamentally reshaping software engineering. Drawing from a curated set of 12 research papers published on June 16, 2025, this session delivers insights into how coding, repair, security, and user experience are being transformed. Special attention is given to Sun and colleagues' landmark study on automated program repair. Join us as we chart the future of smarter, self-improving software. Consider this. The latest update to your favorite app likely involved artificial intelligence in writing, repairing, or designing its code. The boundary between human creativity and machine intelligence is rapidly blurring, leading to a world where software can almost write and repair itself. This raises significant questions for millions of developers, testers, and users who depend on reliable software. Today's research investigates this evolving partnership, revealing how AI is interwoven with the creation and maintenance of modern applications. The DNA of software is evolving at an unprecedented pace. Artificial intelligence, and in particular large language models, are now writing, fixing, and designing code at scale. These models are at the core of a revolution in software engineering, influencing debugging, user interface design, and security. Researchers are actively exploring the methods, stories, and implications of these changes. Today's journey will move from examining how code is written through program repair to considering the future possibilities enabled by these innovations. To understand these advances, envision software engineering as the nervous system of a city, a complex discipline that connects theoretical computer science with practical system building. Traditional methods, such as manual debugging and requirements documentation, still persist. However, artificial intelligence is rapidly modernizing this landscape, much like new skyscrapers rising alongside older structures. This blend of tradition and rapid AI-driven change poses challenges around reliability, adaptability, and user satisfaction, making the field more dynamic than ever. Large language models, as highlighted in studies by Sun, Zhang, and others, function like polymath apprentices in a software workshop. Trained on vast code bases, they are capable of spotting complex patterns, reasoning about code structures, and suggesting improvements. In many cases, these models outperform traditional tools in tasks like program repair. Nonetheless, their performance on ambiguous or complex problems still relies on human guidance, illustrating an ongoing need for expert input in challenging situations. Automated program repair is analogous to a network of self-healing roads that detect and fix potholes before they become problems. Research by Sun, Liu, and others demonstrates that artificial intelligence can detect and patch bugs significantly faster than manual methods, with particular strength in identifying and correcting regression errors. Integrating human-in-the-loop systems further enhances reliability. Central to this domain is empirical benchmarking, where AI systems are tested on real-world code bugs to validate their effectiveness. Security and user interface development represent the next frontier, introducing both new risks and remarkable capabilities. Research by Wang and colleagues shows that emerging protocols, such as the Model Context Protocol, introduce unique vulnerabilities like tool poisoning, which are specific to AI-driven systems. On the user interface front, work by Tang, Chen, and others demonstrates how AI-generated front-end tools can transform sketches into polished dashboards. The distinction between static and dynamic analysis, evaluating code with or without execution, plays a critical role in both securing and optimizing these systems. Several striking findings emerge from the recent research. Sun and collaborators show that specialized large language models outperform larger, more generic models in bug-fixing tasks. Liu and colleagues find that providing contextual information nearly doubles the effectiveness of language models on regression bugs. Wang's work highlights the necessity for smarter security defenses for new AI protocols. Meanwhile, Tang's DesignCoder AI achieves industry-grade user interface code generation. Collectively, these stories indicate a shift toward greater specialization and human-AI collaboration in software engineering. A focal point in today's collection is the study by Sun and colleagues on large language models for automated program repair. This work evaluates 4 prominent models: CodeLlama, LLaMA, StarCoder, and DeepSeek-Coder, across Java, C, C++, and Python languages, 2 types of bugs, 4 prompting strategies, and 6 established datasets. In total, more than 600,000 code catches are analyzed to assess quality and precision. The research addresses a pivotal question: are large language models truly effective for real-world program repair? And does model size correlate with success? Key insights from Sun et al.'s study challenge the prevailing wisdom that bigger models are inherently better. CodeLlama, which is fine-tuned specifically for coding tasks, outperforms larger, general-purpose models. There is no straightforward relationship between model size and the ability to repair code. Interestingly, correct bug fixes frequently appear early in the AI's output, indicating potential for optimization. The study underscores the importance of prompt engineering, how questions and instructions are framed, and affirms that expert human guidance remains essential for nuanced code repair. The human impact and methodology behind Sun et al.'s work are notable. Their rigorous, language-diverse benchmarks set a new standard for evaluating large language models in software repair. The findings advocate for increased collaboration between humans and AI, rather than simply scaling up model size. The researchers' motivation centers on helping developers spend less time finding and fixing bugs, thus promoting a more productive partnership. This approach paves the way for practical, reliable AI integration in the future of software development. Looking ahead, the future of software engineering resembles a city with fleets of autonomous vehicles, hybrid AI-human systems working in tandem to maintain and improve the urban landscape. Artificial intelligence models are expected to learn from every repair and user interaction, making software systems increasingly adaptive and self-improving. However, new security risks necessitate ongoing vigilance and a focus on user-centered design. The research community aims to develop software capable of dynamic adaptation, repair, and growth, with collaboration and adaptability as the hallmarks of future breakthroughs. In conclusion, large language models are revolutionizing code writing, repair, and user interface design. However, this progress must be matched by advancements in security, reliability, and human-centered design. The work of Sun and others demonstrates the value of specialization and collaboration. The next major breakthrough could originate from anyone in the field. Listeners are encouraged to delve deeper into the research, participate in discussions, and actively contribute to shaping the software engineering landscape of tomorrow. To create this episode, content was synthesized using GPT 4.1 for summarization and narrative construction. Text-to-speech systems and image generation tools supported the creation of multimedia elements. A human expert reviewed the final content for clarity and accuracy, though some oversights may persist. Listeners are encouraged to cross-check references as necessary. Full references and details for all discussed papers are provided for those interested in further study. Subscribe to AI Frontiers for the latest breakthroughs in artificial intelligence and software engineering. Stay informed with expert analysis and in-depth explorations of the most recent advances. Channel AI Frontiers. Thank you for joining us as we explore the evolving world of AI. Please share your thoughts and questions in the comments. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.